In this video, we're going to talk about histogram. Histogram is actually a bar graph whose bars are directly beside each other. And because of this, they are often used for interval or ratio variables. The reason why the bars are directly beside each other is because the interval or ratio variables might be continuous. So here's an example of a histogram here. As you can see, we have bars here from this specific groups that are beside each other, and there's no space in between. The first two making it quite indistinguishable which bar is which actually. But we can set that our histogram can be distinguishable. They're bars. That's what I meant. So this is an example of a histogram, a bar graph usually for interval and ratio data. We're going to get more information about the histogram, but first let's construct it in Excel. Alright, so here we are in Excel, and again we have our data here, which is food expenditure. So here we go. So how do we create histogram in Excel? So again, we go to Insert, there you go, and then we go to pivot table, and we select, just to make sure that we have selected everything, there you go. Alright, once you have clicked select, you can make the table on the existing worksheet like before. So I'll choose existing worksheet here. There you go, then click OK. And just like before, we make our food here. Then the values, make sure that in value field settings, it will be count. Just like how we do our frequency distribution table. Let's group them. I'm going to group them based on Excel. So there you go. And now we make our bar graph like how we do it before. So we now go to Insert. Here's our 2-column. And there you go. Now how do we make this into a histogram? We now right-click and Format Data Series. So here you can see some of the things that we can adjust. And what we need to adjust is actually what we call the gap width, which is this one here. There you go, gap width. We're going to make the gap width 0%. So let's make that 0%. There you go, 0. And there you go. Let me just close. Wait a moment. There you go, and let's now close these. There, and let's make it a little bit bigger. Okay, and there you go. We already have our histogram. We can change this into food expenditure if you like. If you don't like, that's perfectly fine. Let's close this again. And here is our histogram. Now, if we're going to see, you can see that the concentration of our data is somewhere around here. So you can see that there's a, if you're going to draw this as if it's a curve, there's a large lump like that. Let me draw that here outside. It's kind of look like that. Or more rather, of our data is focused here on the left hand side. This is, if this is your center right here, then it's more on the left hand side. And the shape of our histogram is usually important because it gives us valuable information. Further, even the tails of the distribution of the histogram is important and gives us some valuable information. And this information that I'm talking about, the shape, is skewness, and the one about the tails is about kurtosis. So first, let's talk about skewness. When you say skewness, it's usually denoted by SK. So this is the formula, although we're not going to manually compute it, we're going to use Excel like before. But here's how we interpret skewness. If our skewness is greater than 0, then the data is positively skewed or skewed to the right. It might look something like this. So if this is our data set, let me draw our histogram as a curve already. It's a combination of so many small bar graphs. So it's here. If this is the center of our data set, it's more here lumped on the left side. So our skewness is greater than 0, and we call this positively skewed, or skewed to the right, because as you can see, it's the right side that has lower, or has rather a deformed value here. If skewness is less than 0, then it's negatively skewed or skewed to the left. And we can draw it somehow like this. If this is the center, the values are here more on the right side. We have more high values in positively skewed, more low values. And that is if the value of our skewness is less than 0. And if skewness is equal to 0 or very close to 0, then the data is symmetric. Although I am not good in drawing that one. Oops, sorry. There you go. We got that all clear again. And somehow it looks like this. It's in the center. More of our data are in the center. It's not more left or not more right. It's more in the middle. Skewness is equal to 0. Therefore, our data is symmetric. So if skewness talks about where most of the data are, kurtosis, on the other hand, denoted by K, here you go here, talks about the heaviness and lightness in the tails of the distribution or at the ends of the distribution. And we have different types as well. We have a leptokurtic distribution that shows heavy tails on either sides. That means we have a lot of extreme values. So say for example, leptokurtic might look something like this. So as you can see, there are actually values at the ends. It's not flat just like this one. These are quite flat, but here there are rising. So there are values on the sides or on our tails. And if it's leptokurtic, K is greater than 0. If it's mesokurtic, it shows a symmetric distribution, very much like our skewness. Oops, that's not kind of skewed. Wait a moment. There you go. Let's draw it again. Somehow, there you go. Somehow symmetric. It should be like that. Let's erase that. There you go. So, not very thick and not very thin. And that is if K is equal to 0. If K is less than 0, we call it platykurtic, and the distribution has very few extreme values like this. So very few, very small extreme values. More of the values are just in the middle, a lot more in the middle really, and very few here, and that's what we call platykurtic. So, given skewness and kurtosis, how do we now describe our histogram? We're going to learn about that in the next video.